The American Geophysical Union is committed to advancing Earth and space sciences, with 2023 being declared the year of open science. This year's annual meeting is taking that concept even further.
Welcome to AGU 23.
This is AGU TV,
where today we are focusing on
wide open learning.
Welcome back to our last day here together in San Francisco and to AGU 23. I'm Laura Krantz, your host of AGU TV. As we get started on this fifth and final day together, we are turning to the topic of learning, and specifically how we as scientists can also be better communicators.
Coming up today, we will highlight the Voices for Science program and show you how the AGU is training scientists to be better communicators.
Plus, as open science becomes widely adopted, it's important to take the time to meet as a community and share our knowledge, or sing it. We will highlight best practices straight ahead.
When it comes to open science, accessible data is pivotal. I'll highlight how community-driven data is making science available for all.
And I will highlight how the AGU is using environmental observations to improve health decision-making, something we can all benefit from.
You can find the latest AGU TV episode on the TVs placed throughout the convention center, on the in-house channels at several of our partner hotels, on the homepage of the AGU website, and on our YouTube channel and on X, formerly known as Twitter. In 2018, AGU launched its Voices for Science program to train scientists in science policy and in media and community outreach. Natalie Rea is a postdoctoral research associate in the School of Information at the University of Arizona. And just recently, she was selected to be a 2023-2024 Voice for Science. She joins us today to talk about the program. Thanks for being here, Natalie. Tell me about the Voices for Science program.
So this is a program that AGU runs on an annual basis, and it involves people from all different career stages who are interested in becoming advocates for and communicators for science and the value of science. And so we have a cohort of people that come together, scientists from across the US, Canada, and Europe, and we receive training through AGU, and then over the course of the year, we each execute outreach tasks where we're based. And we have this network that helps us develop programs and outreach that we do where we are.
It sounds really cool. What made you want to get involved?
I was in the middle of my PhD. I worked on rock geochemistry, and I wanted to find a way to kind of feel more connected to people and find ways to better communicate my science. And so this was a fantastic opportunity that allowed me to still continue to do my research and simultaneously get training and outreach and support.
Why do you think it's important to train scientists in communication, in media relations, in public policy? Like, what's the benefit of doing this?
I think, increasingly with social media and news sources, we have a great need for hearing the voices of scientists and explaining and bringing the science to people. You know, taxpayers invest a lot of money into the research that we ultimately conduct, and so I think we also have a responsibility to tell people what we're doing and share the exciting work we're doing and the realities of the scientific process.
Yeah. I'm curious, I'm assuming you received some training on this, on like how to do these kinds of things. Like what did that look like? How did that sort of proceed?
We were all brought together in DC for a 2-day workshop, and that kind of kicks off the Voices for Science program. We hear from people that are both at AGU and also are kind of out on the ground, so to speak, in DC doing this work. And so we have conversations and goal setting. And then really the rest is kind of learning by doing. And over the course of the year, we also have access to a number of other types of webinars where we receive guidance on best practices for communicating with staffers, but communicating with the public, whether you're doing K through 12 outreach versus talking to news media, et cetera.
So you have to kind of be able to take what you're working on and be able to talk about it in a wide variety of fashions, depending on who your audience is.
Exactly. It's a lot of learning to tailor your message and kind of meet people where they are and understanding what might be compelling to different people, what their interests are.
How does the Voices for Science fit in with this year's theme of open science?
We talk about open science from a scientist's perspective. It means things related to publications and data access and data availability, but there's also kind of a broader umbrella that's about who is the science for, who has access to the scientific results, and certainly the public and outreach is a part of that. And so absolutely, I think Voices for Science and communicating science to the public is part of open science.
Great. Natalie Rea, thanks for joining us today.
Thanks.
Open science can help scientists make progress on their research and find helpful collaborations. Kirsten Laner is a senior research scientist at Lamont Doherty Earth Observatory at Columbia University. She's also an advocate for open science, having pioneered efforts on transparent and reproducible science. Kirsten joins us now to talk about why open science is important at every level of research. Thanks for being here.
Thank you for having me.
How did you come to recognize the value and importance of open science?
I think it was in direct experience in working in a field that makes data more usable to broad audiences and seeing the impact that had in completely new science paradigms, in the sharing of information and the science that came out of it that would not have been possible if the data hadn't been shared in this open manner on the web to make it accessible. And I've been tracking how that happens in other fields, and it's just a very positive development.
And when we were talking about sharing, we're talking sharing, data, results, samples with other scientists, right?
Yes.
And then you're also talking about sharing what you find with the general public or policymakers or community leaders, depending on what you're working on.
That's absolutely true. I mean, there is obviously the big field of publishing, the scientific sharing of knowledge. There is also an aspect of sharing it with the general public through, efforts of community engagement, of political engagement, actually advocating to governments, to decision makers, and so on, what is available. So they are different aspects, but sharing more openly the scientific knowledge really empowers the scientific community to the big challenges of our days for society. And clearly in the earth environmental sciences, there is a lot to address. And the more open, we can share our knowledge, the more people can participate in it.
Scientific publishing has sort of been known for being kind of closed and expensive, and you have to have a subscription, and the subscription's expensive, and it's hard for everybody to get that information. What do you see changing in publishing, or what needs to change in publishing?
There is a push from institutions, from funders, to make scientific publications more accessible. For example, in the US, the National Science Foundation requires the researchers funded with public money to put their publications into publicly accessible archives and so on. So there is a big movement to make the scientific publications more open, but there are also some challenges with respect to funding these efforts in operating journals. New ways of peer review have to be found for those journals that are more open, and they're being explored right now. There's a lot of testing going on what new paradigms can be used.
Yeah. As you are talking to the next generation of scientists at places like AGU 23 and other conferences and in your institution, what are you telling them about open science and what they need to keep in mind as they're doing their own science and their own research?
They clearly need to think about different ways of doing things from the beginning on, sharing their results, collaborating with others. From my perspective in the data world, it's really important to know from the beginning of a research project how to document all the workflows, all the materials, the software that has been developed and so on, to make it actually shareable. Because just putting something out there without letting people know how you generated your interpretations, how you generated your code, or how you performed your analytical work, makes the data not reproducible. So you have to approach your scientific work in a different manner.
Thank you so much for joining us today.
Thank you.
Turning now to an incredible partnership for the future of AI. NASA's Interagency Implementation and Advanced Concepts team and IBM have collaborated to create a groundbreaking new foundation model for AI. By bringing together the incredible data gathered by NASA and the intricate technology of IBM, they've created the Geospatial AI Foundation Model. Take a look.
NASA's Open Science Initiative is really an incredible opportunity for more people to interact with NASA's incredible scientific data. It's really about including more people in the scientific process, opening that process so it's more transparent, and really enabling people that traditionally haven't worked within NASA to be able to work with the information that we collect.
We followed the open science principle from the start, right? We did everything in the open. But when we released the foundation model in the Hugging Face, which is the open repository of AI models and data sets, we immediately saw community picking it up and developing their own applications. The proliferation of these models and data set following the open science principles, I think that was our initial goal, and I think we've succeeded in that.
Climate change goes hand in hand with increasing environmental health risks, from water and air pollution to extreme heat to food insecurity. By paying attention to changes in the environment, governments and public health officials can make decisions that will improve people's health outcomes. For more on this, we're joined now by Helena Chapman. She's Associate Program Manager for Health and Air Quality Applications in the Earth Action Program with NASA's Earth Science Division. Thanks for taking the time to be here.
Thank you for this opportunity.
So tell me a little bit about this relationship between climate change and environmental health. How are the two interrelated, and why is this important to look at?
Earth scientists are examining how our Earth is changing, the different systems when we think about the atmospheric, the terrestrial, and the aquatic ecosystems. And those have living organisms such as humans, animals, plants, among others, and how that can affect. So as we're seeing increased temperatures, increased precipitation, deforestation, we're seeing that those elements can actually impact exposure to harmful hazards, including vector-borne diseases. And so that's when we start thinking about the One Health concept, thinking about a little bit more holistically about how we view health.
Can you tell me a little bit more about One Health, like how this idea came to be and what it is?
So the One Health concept really has a two-part approach. The first is looking at the interconnectedness between humans, animals, and the environment. There are these links, and one will affect the other. The second part is really to look at a call to action to work outside of our silos. So earth scientists working with health practitioners, working with veterinarians, working with the agricultural sector, the ecological sector, the tourism sector, working across all of these sectors to really better understand how these changes to our Earth systems are impacting human and animal health.
So the information that scientists are gathering about, Earth's health, human health, plant health, animal health, these kinds of things, then that information is useful to policymakers and to public health officials for them to be able to make decisions. It seems like an awful lot of information. How do you figure out what information is useful and what's just too much and might make them feel sort of like they're drowning in data?
The One Health Joint Plan of Action 2022 to 2026 really lays that out. It was launched last October, and the sixth action track actually states integrating environment into One Health. And that's going to be really important because health practitioners do not have all the answers. really no one discipline has all the answers, but being able to collaborate across disciplines, we can provide that information. And earth scientists, as they're studying how the Earth is changing, have been able to develop robust models and algorithms for disease forecasting. So if you have the information 4, 6, 8 weeks ahead of time of an at-risk area for a potential cholera or malaria outbreak, you can provide that information to those who are the urban planners, the policymakers, the mayor, or the leader of that community to be able to make some of those decisions to protect health of their community.
Yeah, all of this seems to fit really well with this year's theme at AGU of wide open science. Can you talk a little bit more about how open science really dovetails nicely with what you're talking about in terms of the One Health?
The open science to me is being able to make the information available to the globe, whether that is a scientific research finding or if it's a public health message. And from a public health angle, we can see that information being translated appropriately to the community who needs that information. The World Health Organization has identified 13 urgent challenges in 2020. Of that, one of them is harnessing new technologies. So being able to adapt some of the information we have and data resources from the earth science community and adapt them to other communities, other ways of being able to analyze data. And the second part, another urgent challenge, is actually being able to build public trust. And that we've seen throughout previous pandemics, such as Ebola and COVID, where the infodemic has been a challenge to those who are working on the ground. And so how can we bring some of the information from the Earth observing satellites to validate the information that we have, integrate it with some of the public health surveillance data, which have limitations in itself, and to be able to really understand what is a disease burden or the hazard burden for that area, for thinking air quality, for example, to be able to provide accurate and prompt health messaging for those communities and for those leaders who are making decisions.
Helena Chapman, thank you so much for your time today.
Sure, thank you.
As we are wrapping up an incredible week here at AGU 23, we wanted to hear from attendees one last time. We hit the conference floor to ask the question, what have you learned this week? And what makes AGU such a great hub for learning?
At this AGU, I've learned new technologies and new tools to work with geophysical data. So that includes cloud computing or looking at different machine learning algorithms. And so that sets up for how I might attack problems in the future.
At AGU 23, I've learned that science is applicable and science is fun.
I've learned that earth sciences and science in general is extremely interdisciplinary, and that's when we make the best discoveries.
I've learned that there are so many different types of disciplines of science, and they all kind of come together to explore different technologies in science.
Most interesting session, I think, from my perspective, is about poetry and science. And yeah, it was amazing how poetry can help to better understand science for people not involved in this field.
I work in permafrost dynamics over the Hindu Kush Himalaya. I met a lot of scientists from the region, and I learned the latest science technology, and I built the coordination with different stakeholders.
I think the coolest thing about science is realizing that you don't have to do it in a vacuum or by yourself. You can leverage your own expertise, but also of your colleagues. And so you get to learn more and take away from that.
Science is a collaborative effort, and it's really great that there's so much diversity here, and we're able to actually talk to people from all over the place and kind of get their insights.
Science is open when science is accessible.
Science is amazing because it's exploratory.
This world is really big, and you can go at the macro scale and research that, or go at the micro scale and learn, and it's just endless in the possibilities of what you can research and learn.
Science is unity, and it is just amazing to see all research around the world and see people of different cultures, and this is amazing.
Rowan, thank you so much for joining us today.
Thank you. It's great to be here.
So, what is CurveNote?
CurveNote is a platform for scientists to help them communicate science in sort of a more authentic way, especially with computational notebooks so they can show more of their research, which is the data and the code and sort of all of the interactive graphics behind their research.
So it makes it more accessible to more people, or like layman general guy out on the street would be able to look at this and kind of have an idea what's going on?
If you think about how science is communicated today, it's all about sort of PDF documents, and there's like a classic picture that I use of a mobile phone with a 2-column PDF that you're like sort of zooming into one side and zooming out, zooming into the other side, and there's a table that's on its side. And like the way science is being communicated hasn't changed in hundreds of years. We've moved from paper into PDF documents, but the way that scientists are working has changed so much. We're using supercomputers and like all of this data and visualizations and being able to interrogate it. And so that sort of divergence of sort of how we're communicating and how we're working as researchers, there's like a dissonance there. And that's sort of the part that we want to help fix.
Okay. So the theme for AGU this year is wide open science.
Yeah.
How does CurveNote fit into that?
We're working with AGU on a new initiative called Notebooks Now.
Okay.
And it's trying to change how science is communicated with these computational notebooks. And so we're putting that at sort of the center of how we can communicate science.
Yeah. Can you give an example of like something you were trying to communicate and you were like, the tools here are really failing me?
My PhD was in computational geophysics, and so I was creating tools for my peers and then going out into educational contexts, and we did sort of a lecture tour all over the world. You want to see electromagnetic fields and like play with the conductivity of different parts and see all of the fields and fluxes. And you can't communicate that in a PowerPoint slide. You can't communicate that in a static document. You need like either a magnet and iron filings around you where you can like change the magnet, or you need a computer to actually simulate it. And so we were sort of merging those two ways of communicating. And I think the students got so much more out of it, and it's also tied to the actual research. And so you're bringing students through education and through to cutting edge research in a much clearer way than a PowerPoint slide or a PDF where you just stop.
Yeah. Are you seeing scientists adopting this? Are they excited about the possibilities? And then like, how do you see this changing science and science education?
There's like 20 or 30,000 computational notebooks published using some of our tools. And so I think there's a lot of drive. Where it hasn't quite gotten to yet is sort of that professional scientific publishing communication. And that's what we're working on with AGU, is to try and take it all the way so that people can get full credit and share all of their work.
And this fits in pretty well with like open access and like making sure that people can see all these materials and see the great work that all these scientists are doing.
What I sort of think about when I think about open science is sharing more of your work and really communicating as much of your research as openly as possible, but also communicating fully so that you can build upon someone else's work, stand on the shoulders of giants. That's sort of the ethos of science, is building on other people's work. And if you have like a paragraph or a sentence in a PDF document that says, like, I use this method, and then you have like all of your code and notebook and data over here that you're not sharing, then you can't build on that. And so that's like really impacts the dissemination of knowledge and the ability to build upon other people's work.
Rowan Cockett, thank you so much for coming in and talking to us about CurveNote.
Thank you. It's been a pleasure being here.
Turning now to NOAA, the Ocean Exploration Cooperative Institute's commitment to explore, map, and characterize our nation's vast ocean territory. Let's see now why the ocean is critical to the health, wealth, and security of the United States.
The Ocean Exploration Cooperative Institute is a consortium of 5 institutional affiliates, and together we work with NOAA's Office of Ocean Exploration to develop new technology, conduct exploration, and educate and train the next generation of ocean explorers and blue economy workers.
A relatively small amount of the world's ocean has been explored. Only about 24% has been mapped to any degree of resolution. Around the US, around our exclusive economic zone, only 50% has been mapped. The ocean provides countless benefits to the planet, the nation, and the people who live around it. We're all impacted by the ocean. And through ocean exploration, we can provide new insights on how the ocean affects our lives.
We critically rely on the ocean, and having as much information about it is what the Ocean Exploration Cooperative Institute is trying to provide.
Open science can lead to inclusivity and accessibility and make science more robust. Sharing tools, best practices, and challenges can help further the goals of scientists, as Paige Martin can attest. Paige is a support scientist at NASA, and she joins us now to sing the praises of open science. Thanks for being here.
Thank you for having me.
So AGU has been talking about open science all week. Tell us why this is important.
Open science is what science is meant to be. It's meant to be something that really serves society, that benefits society, and that can benefit everyone in society. So the idea of open science is that we share our science, we're sharing our data, we're sharing our code, we're sharing our results openly, but it's not just about the sharing, it's also about the people. It's the collaboration, making sure that we're thinking about how we're doing our science and that it's inclusive and that it's equitable. And I'm really excited to see AGU really embracing that this year.
Give me a few more examples about how it can improve, research and learning in these wide variety of scientific fields.
There are a range of examples. One specific one that I like to share is about how making our data more available can actually increase the science that we're doing and benefit science in ways you might not even think about. So this particular example is about a radar data set that is it's NexRad radar. It's usually used for meteorological data sets. Tracking atmospheric phenomena is what we often use when we look up weather patterns. This data set's been used for many decades, and there was a NASA-funded study that looked at how that data can be used to study birds and bird behavior as a result of changes in the climate. So it turns out that birds are also tracked, not just weather patterns. So that's an example where the people who put the data set up had no idea that the bird community would be able to use this, and it enabled new types of science.
That's really cool. I'm curious a little bit about how AI and machine learning fit into some of this stuff, because I know there are some problems with, how factually accurate is this information? Like, how do we take advantage of these technologies without getting perhaps bogged down in some of the pitfalls?
That is an excellent question. I will say I'm not an expert in AI or ML, machine learning, but these are going to be important tools. So I think a lot of open science to me is what science was meant to do, but we couldn't do in the past because of kind of these very physical challenges. Like we had to physically have access to a university library to get access to journal articles, that kind of thing. These advancements like personal computers, Wi-Fi, internet in general, really transformed our society. And I think, to me, open science is kind of catching up, is like, this is making sure that we're actually taking advantage of those advancements. And I think artificial intelligence and machine learning are kind of another societal advancement that we are seeing right now. And I think it is something that we absolutely need to embrace, but we do need to be cautious about it and make sure that, we are doing quality science, but making use of these tools.
So it's fair to say that you love open science. And
Yes.
I have heard that you love it so much that you actually wrote a song about it. Would you be willing to share that song with us?
Would I? I would love to. Thank you for asking. I will clarify, I did not write this song, but I wrote lyrics to the song, and I even brought a backing track.
You were prepared.
I was prepared. All right. Sometimes I do a little dance.
Oh,
but
okay.
I'll spare you the dance today. We'll stick with the music. I am lonely and sad doing my PhD. Rerunning others' results unsuccessfully. The data's not shared, nor is any code, it just isn't fair. How much time I spend reproducing, and there's no transparency. just 2 words that I heard someone say. I need those words to help me find my way. Whoa, open science, what a great idea. My, how could I resist you? Open science, you have me in your thrall. Open science is for all. Yes, I was sad and lonely until I found this community. My, I will never look back now. AGU, by now you all should know. Open science is the way to go.
That is amazing.
Thank you, that was really fun.
Paige Martin, thank you for joining us today.
Thank you so much, this has been great.
It has been an engaging and exciting week here together in San Francisco for AGU 23. We hope you have enjoyed the specially curated content, sit-down interviews, and the packages highlighting key sessions and speakers. You can rewatch any piece of content from this last week by finding the AGU TV playlist on our YouTube page. Thanks again for your time this week, and we can't wait to be back with you again next year. Safe travels, everyone, and Happy New Year.